Welcome to Lockheed Martin Space Makers. My name is Ben, and I'm your host. NASA's Artemis 1 mission is about to launch the Orion spaceship to the moon. Over the next few weeks, we'll be doing special coverage of the launch and Orion's mission. You can also watch these special shows on Lockheed Martin's YouTube channel. Today, experts from Lockheed Martin discuss NASA's Artemis 1 mission and how Orion is the only spacecraft uniquely designed to take humans into deep space. Now let's go for launch. NASA is about to launch the Lockheed Martin designed and built Orion spacecraft to the moon. This mission to the moon is called Artemis 1 and is part of NASA's Artemis program, which aims to send humans back to the moon to stay. The ultimate goal is to use the moon as a proving ground before humankind's next giant leap, sending astronauts to Mars. Artemis 1 will test NASA's deep space exploration system, comprised of Orion, the only spacecraft in the world designed to take humans into deep space, launched on the largest rocket in the world called the Space Launch System, or SLS for short, and the new ground systems at Kennedy Space Center in Cape Canaveral, Florida. Orion won't be taking any astronauts to the moon on this mission, but NASA will be performing critical tests and demonstrating the capabilities of sending humans to the moon in future Artemis missions. Over this 3 to 6 week mission, the uncrewed Orion will travel well over 250,000 miles out to the moon, where Orion will fly within 62 miles from the lunar surface. It will then travel about 40,000 miles beyond the moon, making Orion the farthest spacecraft built for humans has ever flown, all before returning to Earth. In today's episode, we have a roundtable discussion with experts from Lockheed Martin discussing the Artemis 1 mission and how Orion is the only spacecraft uniquely designed to take humans into deep space.
Hi, my name is Lisa May, and I'm the Chief Technologist for Lockheed Martin Commercial Civil Space. Joining me today is Carrie Timmons.
Hi, Lisa.
Hey, Carrie, and Tim Chihan. Hi, Tim.
Thanks for having me.
And we're going to talk today about Orion. Why don't we start out by having both of you tell us a little bit about your role at Lockheed Martin and on Orion? Carrie, why don't you start first?
Sure. I am the Orion Systems Engineering Manager, and I'm responsible for requirements and making sure all those are verified, as well as all the interfaces, electrical, mechanical, and also making sure that the onboard crew can interact with the vehicle and all those human interfaces.
Thanks, Carrie. Tim?
So I'm the space exploration architect for Lockheed Martin, and I lead a team that develops advanced concepts for human and robotic exploration of the moon and Mars and beyond. But I also spent about 10 years on the Orion program in a variety of roles, starting in launch abort trajectories and going all the way through as the Orion system architect.
Wow, that's great. I'm so lucky to work with both of you. Let's start with a few questions, shall we? The first one is, the Artemis program aims to go back to the moon to stay. Can you speak to the significance of this program's mission and going back to the moon this time?
Sure. So going back to stay means a couple of things. One is that we're planning for a long-term program of exploration, both in orbit and on the surface of the moon. We're planning to use the resources of the moon. We're planning to have a way station in orbit around the moon called the Gateway to go to the lunar surface, as well as to get ready for Mars. And that long-term planning has influenced the design of the different vehicles, including the Orion spacecraft and its mission. And so, unlike Apollo, Orion is designed to have solar arrays, to have power for as long as it needs, to have life support that instead of relying on disposable canisters can actually cycle the CO2 indefinitely. It's 4 crew instead of 3 crew, a lot more capability. It's also a bigger spacecraft. And of course, it's got modern computers and avionics and a lot more data and HD cameras and all sorts of the things that we need for going to the moon and performing a lot longer, more intense science and exploration.
Yeah, exactly. And as you alluded to, we're going there not just to gather data and do experiments, but to stay, to build up a lunar base and learn what it takes to just live on a body other than Earth, one without atmosphere, in this complex environment to help us prepare for farther, deeper space exploration. And also, Orion has capability to bring samples, return samples back to Earth for additional experimentation here.
Yeah, I mean, and one of the things that always strikes me about this is the fact and I think, Tim, you and I've talked about this previously, it's a little like when you move away from home and you have to set up your own place. And we like to talk about Earth independence. And it's helping us, Orion is a piece of the picture of helping us move to power, light, heat, utilities, comms, your best friend's pickup truck, and all of those other things that we're going to have on the surface of the moon because we're going to stay.
Exactly.
So could you walk us through the details of the Artemis 1 mission and some of the challenges that Orion is going to face during the mission?
Yeah, absolutely. I'm so excited for Artemis 1 because there's so many firsts and so many initial tryouts we're getting to do. It's the very first time that we'll see the integrated Space Launch System and Orion vehicles operating together. But beyond all the firsts, to talk about this specific mission, depending on which day we launch and the relationship of the moon to the Earth, we'll have either a 26 or 42-day mission. We'll launch from Kennedy Space Center and perform some burns to get out to the moon, where we'll have a lunar flyby and enter a distant retrograde orbit, and then perform another lunar flyby to actually assist us getting home, where we'll re-enter the Earth's atmosphere and the crew module will land safely off the coast of California.
I want to pull on one of those things you said for just a second, Carrie. You noted that depending on when we launch, the mission might have a different duration. Is that true just because this is the first one, or will we be designing missions to be flexible in the future?
We definitely have an opportunity to have flexible missions. We want to have the most launch window availability that we can to accommodate for weather and just the various different aspects of planning and logistics that go into a mission. This one's a little bit longer just to give the full demonstration period of all those advanced avionics and components that Tim talked about.
Yeah.
The other interesting part of the Artemis 1 missions and the follow-on missions is that the orbit that Orion is going into is affected by both the Earth and the Moon's gravity at the same time. So it's not an orbit around the Earth or the Moon, it's around both. And that adds complexity, and these stable orbits that NASA's picked are places that we haven't put spacecraft before, so that'll be another first.
Yeah, that's really exciting. So what is there more than one Orion? We talk about Orion. Is it just the one, or are there more? And are they reusable?
That's a great question, Lisa. And yes, there are several Orion vehicles or Artemis vehicles for the Orion capsule. And that's a really important part of our actual long-term affordability strategy. Obviously, each spacecraft has a lot of complex avionics, environmental control and life support systems, propulsion, and all that's expensive. So if we can reuse those advanced high-end components many times, then it keeps the overall cost of each mission down, which enables us to fly more regularly. So right now, we're actually putting plans in place to reuse components from Artemis 1, some of the avionics in the crew seats, onto Artemis 2. So even the first mission has reuse. Artemis 2 has more components being reused, and on Artemis 3, the physical structure of the vehicle will be reused for subsequent missions.
Oh, that's a really exciting evolution. So there are multiple Orion spacecraft actually in existence right now, not just the one that's about to launch, right?
Yeah, that's right. I mean, we've got Artemis 1 that's on SLS at Florida. Artemis 2 is in checkout. Artemis 3, 4 components are being built, starting to come together all across the country. It's a really exciting time.
Yeah, proof pressure test on Artemis 3 is just a few months away. So
that's great.
Oh my goodness.
Yeah.
That's going to be another milestone that maybe people don't recognize how important that is. But certainly for keeping humans safe in deep space exploration, that's huge.
Yeah, and as we move through our emissions and learn things. We're going to apply them back into the program, figure out what can we reuse and increase that reuse more and more, and then also figure out how to evolve Orion's design as it moves into the future and all the new missions. So it really is a dynamic program moving through the decades.
That is going to be so important as we go forward. Artemis 1 is uncrewed. We know this. So when will astronauts actually fly? And what else do we have to do to Orion or the future Orion spacecraft in order to make it ready for crew?
Thankfully, Lisa, we don't have to wait too long. Artemis 2 is not far behind Artemis 1, and it will be the first crewed mission, taking the next man and woman astronaut farther into space than any human has gone before. So there are a few differences between Artemis 1 and Artemis 2 to support the human experience. When you drive your car, you need AC. You want to make it hot or cold. You will need to interact with your vehicle, and you have so we have displays and controls that allow the crew to see what the status in all the systems are, and actually provide inputs and control the vehicle. And then the environmental control and life support, the making sure they have fresh air to breathe, and temperature control and humidity control, whether they're working or exercising or sleeping.
Wow, that sounds really customizable. I like that. Sounds like it's going to be a good ride for the Artemis 2 crew and the crews after that. Tim, anything more about getting ready for crew?
Well, getting ready for crew has been the focus of the Orion program since the early 2000s. And this moment where we're doing the last uncrewed flight, the last uncrewed test flight, and then moving into operations at the moon with people, that's so exciting.
It really is. So, it looks a little Apollo-like, right? The Orion spacecraft looks a little Apollo-like. And you've spoken a little bit earlier about some of the differences. Are there other differences between Orion and Apollo that you might want to feature and talk about?
So I think that the things about Orion all go to that sense of long duration. So solar arrays for the power, and also taking advantage of things that didn't exist in the Apollo era. So we've got more advanced cameras. We've got multiple sets of computers. Now, for the Apollo program, they had to invent flight computers for the most part. It was one of the first aerospace vehicles with a computer. But now the amount of telemetry data that we generate, and therefore how we understand the spacecraft, is truly, of course, decades later in technology. And also from a safety perspective, our abilities when we're coming back and doing reentry and knowing all the things we now know about that test campaign, both in the Apollo timeframe and shuttle up till now, is very interesting. And one of the neat capabilities that is really an important safety improvement is something called skip entry. And so that's when we come back from the moon, we hit the Earth's atmosphere, and we actually pop up above the Earth's atmosphere a little bit. That gives us more time to control the spacecraft and have a much more precise landing. And so we come down within tens of miles of San Diego instead of having to have the Navy spread across the Pacific waiting for the Apollo spacecraft.
Oh, that sounds very exciting for the astronauts and very, very convenient for the engineers to be able to control that entry a little more precisely.
Yeah.
Yeah.
And their flight controls and their displays will give them a lot more information than the Apollo crews had.
So I just have to bring this up. We've just announced the fact that we're going to have Callisto when the crew goes. Tell me a little bit about this exciting voice command capability. We're demonstrating it on Artemis 1, right? And then it will be a capability available for astronauts in the future. Tell me a little more, Carrie.
Yeah, I'm glad you brought this up because this is a payload that we're really excited for on Artemis 1. It's a partnership with us and Amazon and their Alexa and Cisco and their WebEx app. And so uniting both of those technologies that we all use every single day on Earth, but putting them on a space-rated platform that not only the future crews will interact with, but humans on Earth today and for Artemis 1 will have an opportunity to send questions, or we'll have broadcast too of what is going on board the spacecraft during the Artemis 1 mission.
That's great. So tell me a little bit about what it means for Orion to be the only exploration class human spacecraft. How is it different from commercial vehicles that are going back and forth to the space station now?
So, a couple of reasons make a big difference. One is just the distance from Earth. So, things and infrastructure that's there for spacecraft in Earth orbit, like GPS, are not there. And the distance it takes to communicate back to home is much greater. And then, as well as when you're coming back from the moon, you're coming back at a much higher speed. So you're coming back at 25,000 miles an hour instead of 17,000 miles an hour. But the heat rates and loads don't scale linearly. So it's a much more difficult environment.
Yeah, I love data. So when we're coming back, we'll see temperatures up to 5,000 degrees F on the heat shield. And just a few inches below that, they'll keep the heat shield structure and all those avionics below 500 degrees.
Wow.
So that's a big difference. But I'm glad you asked this question because I think there's a lot of misunderstanding around this one and how different the environments are from within the Earth's protective magnetosphere out to the cislunar environments. And radiation is one of those. Orion has been designed from day one, like Tim was mentioning, with crew safety and crew habitability in mind. And one of the aspects of that is protection against radiation. And the best protection against radiation is mass. So the crew module has been designed with mass placed strategically about the crew module to best protect the astronauts. And that's a lot different than the environment seen on ISS or our commercial spacecraft vehicles that go to ISS. So their vehicles are notably lighter without having to design for this.
Which probably also affects that entry problem as well. But in terms of radiation, I also understand on Artemis 1, we're flying some radiation mitigation payloads. We're flying the Astrorad Vest.
That's right. We have a payload called MARE, or the Matryoshka Astrorad Radiation Experiment. Easy for me to say. But it's a partnership. The Israeli company STEMRAD developed a radiation protection vest, and we're flying it on a torso developed by the German Aerospace Center that'll be instrumented to characterize the radiation environment at the moon. And once we understand that, we can increase our protection mechanisms for the crew that will fly on future missions.
Well, and these are specifically female mannequins, right? They're female torsos because that is even less studied and understood, or have I maybe misunderstood the purpose of using that?
No, that's a great point. Yes, the first women going to the moon will be on these upcoming Artemis missions, and so we need to make sure we understand how to protect for not only men, but also women.
And it's not really specific to the commercial spacecraft that are going back and forth to the International Space Station, but you made a comment earlier, Carrie, about humans going the farthest they've ever gone. And I think folks hear back to the moon, and they're thinking exactly what we did with Apollo. And so in talking about that difference too, is the trajectory different for the Orion spacecraft with humans?
Yes, and the reason is that the Orion spacecraft is going to go to the Gateway as an aggregation point to meet up with the lunar lander. And the Gateway is in one of those weird Earth-Moon orbits, and it's a very high altitude above the moon. And so for the astronauts to get to the Gateway, they'll be going further away from the moon and Earth than they did in Apollo.
Well, that's also exciting and another challenge to keep our crew safe.
Right. And all of this data that we're generating, whether from the radiation, the reentry, or the navigation, this is all getting us ready for Mars. So we're already planning to collect those data sets as we do lunar exploration to help us inform how we're going to go to Mars.
Yeah, and part of that, you move a little bit away from home, and then you actually move way across the country. The analogy doesn't break down too quickly.
Well, it's really pragmatic too, right? When you're learning and you're practicing new things, you don't want to be at Mars. You want to be a little bit closer so that if you do need to get home, you can.
Right, that lack of GPS, what are the navigation challenges and all those other things, that proximity to Earth lets us do that kind of experimentation and also experiment with the cadence of operations with human missions that we're going to need to perfect before we go to Mars. So
Right, exactly. Yeah, well, and Tim, you talked about not having GPS at the moon and how we have to use star trackers and optical navigation. So not only are we dual redundant, but triple redundant in some cases to make sure that the astronauts are safe no matter what unforeseen circumstance arises.
Yeah, and a lot of the contingency planning around Orion's capabilities, give the crew that ability to come home in all kinds of failures, whether on the Orion spacecraft or on the ground. And I really think it's that going and doing missions in deep space. That's where we're going to learn all kinds of things that the great engineering teams haven't even thought of. And so that exploration and learning how to operate at the moon is going to be so important for getting ready for Mars.
Yeah. So if we can go from the sublime, living and operating at the moon, back to Earth for a few minutes, let's talk a little bit about any advanced manufacturing techniques or anything that was employed in the development of Orion and fabrication and test of Orion. Anything we particularly did that's new and innovative in that area?
Yeah, I think maybe you're alluding to some virtual reality or augmented reality techniques that we've inserted. My son just got a virtual reality video game, and it's so much fun for the whole family. But beyond that, it has some practical applications too, right? I know that we've really advanced our build and integration processes by utilizing augmented reality. So we have hundreds of heaters and thermal sensors across the vehicle to maintain the thermal environment of the vehicle. And if you think about an engineering drawing and having to go measure out, look at the drawing, look at the vehicle, measure out and place each of those hundreds of small little tiny items, it's time consuming. But if you have a technician that has an augmented reality goggle they can put on with the engineering overlaid on the spacecraft that they're looking at, they don't have to take time measuring, and there's a lot more precision in just putting it right in the spot where the augmented reality is telling it. So that's really improved the efficiency of our build process.
Well, and that's really, the placement of those sensors is really important in terms of both giving us the data we need and the ability to control things on the spacecraft. So getting that right and being able to do it more efficiently is huge. Anything else we've got going on in the manufacturing area?
Sure. I mean, there's new materials that we're using that we haven't used in the Apollo era. There's additively manufactured parts on Orion. And so it is a state-of-the-art spacecraft. And the operations and checkout facility at Kennedy Space Center, where we do final integration of Orion, is using all the most advanced modern techniques to put that together in that very large clean room where Apollo vehicles were also put together.
Wow. The same room?
Same room.
Wow, that's really exciting.
Yeah, and I want to add on because you mentioned additive manufacturing and 3D parts, and I know a little bit about that. On EFT-1, our last flight test, I should say, we only had 4 3D printed parts. They were all passive vents, and when the engineers were together figuring out how to build these, they realized that really the only feasible and affordable way with the integrated filters that they wanted was to 3D print them. So that was a pretty cool breakthrough, and it's just kind of led to more and more designs like that. On Artemis 1, we have over 100 3D printed parts, and on Artemis 2, it's over 200. So,
and I bet that helps with the mass problem too, to be able to make those organic shapes and
that's a great
specially
point.
Designed parts that we could not necessarily make any other way.
Yeah, you can avoid a lot of fasteners and secondary structure when you have it all integrated in a common material.
Wow. Is anything more you want to say about digital transformation? We talked a bit about some of the Callisto and a little bit of the AR, VR that we're using. Is there anything further that we've been doing in terms of maybe systems engineering or other aspects?
Sure. We are using completely computer-aided design in the development of all of the drawings for Orion. We're using system modeling and the best software engineering practices. And we're also collaborating with the people who are building Orion to make sure that it's designed for manufacturability. So when we can even go into a virtual environment and say, okay, here's our biggest box. How are we going to get that installed on the spacecraft? Let's try it in VR. Let's get the information from the people who have to do that on, if you change something over here and made it easier for us to install, that'll save a lot of time. So things like that throughout the whole process is what we've done on the Orion.
And those are the things already integrated, but we're even looking forward. We talked about reuse a little bit earlier, but we're installing what we call life cycle flight instrumentation on a lot of components that'll help us monitor them during the flight, make sure they meet all their environmental constraints, make sure they perform as they were designed. And all that data will be collected and input into what we're calling the Prognostic Health Management System, or PHM. And that's going to facilitate a lot of our logistics for reuse and understanding what the pedigree and what exposure each component has had so that we can confidently say that it's good for several subsequent missions.
Wow, that's really innovative and important. And I can remember sort of the very early days of machine diagnostics, and that is something that's going to really enable us to be effective and reuse the hardware. So it's come a long way since I started my career in predictive diagnostics.
Right. And as we get ready to design the vehicles that go to Mars, including taking Orion to Mars, when we have speed of light delays where we can't talk real time with mission control, the spacecraft systems themselves will need to be able to have access to all that data, to analyze it, and to help the crew make decisions as they move forward on the long missions.
You might call it a digital twin.
Yep, we want to fly the digital twin on the spacecraft so that they have that data right at their fingertips.
I think we've talked about Maya previously, but we don't have to go into all the details of the artificial intelligence it takes to...
Oh, go into details. Oh, tell me more, Carrie.
Maybe Tim can.
Yeah. Well, and that's, part of where we're headed with Callisto, right, is that we want to be able to, with voice interaction, show that we can access those complicated data sets and can work with the systems to understand, hey, is for instance, on a long mission, maybe it's kind of hard to see that there's this component that is having slightly funny data. And so the computer systems can analyze that and say, hey, crew, take a look at this. It might be this or it might be that. But that finding the needle in the haystack of something going wrong, that's where some of the artificial intelligence and the digital twin kind of capabilities are headed.
Yeah, in my head, I'm seeing the sort of the red light on the dashboard as opposed to something very specific that will lead you down a path to solve or prevent problems on the way.
Right.
So back to Artemis 1. What does mission success look like? What does NASA count as mission success? How do they define mission success for Artemis 1? And maybe how do we define it? Are they the same?
They are the same. We've worked closely together with NASA to define all of the flight test objectives for Artemis 1, just as we did on EFT-1. And actually on EFT-1, I was the flight test objective lead on the Lockheed Martin side. And so the most important objectives are the high level, execute the mission, go to the moon, have a safe reentry. Those are the most important criteria for mission success. And then it gets down into tiny little details about, what's the temperature in this segment of the heat shield, 20 seconds after the entry interface point. And so that is all funneling of all the data together to meet the flight test objectives. And we understand that, there's going to be a couple sensors that fail. There's going to be things that we learned new. On EFT-1, we did really well. I think we only missed a couple of flight test objectives because a couple of things didn't go exactly the way we wanted. But everything is ahead of time, clearly planned out. We have all the sensors, whether it's developmental or operational or life cycle instrumentation, looking for all these data points to feed back into our analysis, to understand the vehicle better, and to inform the design as we move forward.
So basically, mission success, if I boil it down, is accomplishment of most of the test objectives, getting to the moon and back, and providing that data that we need to do the next mission.
Exactly.
I would just add that mission success is kind of the hallmark of the Lockheed Martin brand. It's something we put a lot of focus and emphasis on. Every day, it's everyone's responsibility. We come to work and make sure that our components are designed and tested to function to meet our customers' needs.
And sometimes you put your head down and you're doing all the work and you're planning and all of that. And I remember on EFT1, I was in the engineering back room, and there was this moment when we lifted off and I saw the shock diamonds in the Delta IV Heavy's launch vehicle plume, and I was like, oh, wow, we're going to space today. And that's what it's all about.
That's cool.
And so, Carrie, you are still doing the things that I love to do, which is the systems engineering, the requirements, the interfaces, and
The best job.
it is absolutely the best. I often boil that down to what do we have to do, how well do we have to do it, and how do we know when we've done it? And now it's go time. This is when we find out if we've done it. So we figured out what we're doing. We figured out how well we have to do it, which are the test objectives and all of the design and development. And now we're going to go find out if we did it. So this is really amazing. Talk to me a little bit, and we touched on it previously because Tim and I can't help it, is the future beyond the moon for Orion. And as a dyed-in-the-wool Martian, I'm really excited to let Tim open this and jump right in.
Sure. And for a number of years now, we've been working on a concept called Mars Base Camp. And Mars Base Camp is a set of mission concepts and vehicle concepts for how we'll do human exploration of Mars. And that vehicle has got multiple modules, propulsion modules, habitats, but it also includes 2 Orion vehicles. And those Orion vehicles are the command deck for Mars Base Camp, where the crew will command and control. They're also an excursion vehicle along with a propulsion stage going to visit Mars moons. And they also provide a contingency direct reentry back from Mars, where nominal reentry is the Mars Base Camp comes back to the gateway to be reused for the next mission. So a bright future there for Orion and its capabilities for Mars, but also I'm excited about the long-term exploration and activity at the moon, where we're going to be visiting multiple places on the surface of the moon. We're going to have an Artemis base camp on the surface where we'll do extended operations. There'll be cargo and logistics vehicles traveling back and forth from the gateway, landers coming up and down, both robotic and crewed. And so all of that's going to happen here in the future, and these first couple of Artemis missions are getting us ready for that.
Well, and I made the joke earlier about having light and power and communications and your best friend's pickup truck. But a lot of what we're looking at for the future on the moon, and eventually as we go beyond the moon, really is what we like to call Orion Inside, providing that familiar interface for the crew, which makes it safer, which makes it more productive for the crew to be able to interact with their vehicle or their habitat or their spacecraft or wherever they are, because they know how it's going to respond and they know the tools that they're working with. So I think that's also a really exciting piece of this, is that wherever we send humans, we can send them productively and safely.
Absolutely. NASA has invested a lot in the advanced avionics that are in Orion and the safety architecture that's been developed for this, 10 times safer than the shuttle vehicle. We have time-triggered gigabit Ethernet. We have advanced computing systems far beyond what other previous vehicles have had. So rather than reinvent the wheel, let's leverage all of these investments and get to the Mars quickly.
That works for me. So, all right, how does it feel? I got kind of excited a minute ago when I said it's go time. How does it feel? I want both of you to tell me. Let's start with Carrie. How does it feel to know this is happening?
I get goosebumps when I think about it. When I look back at all the years, the time you put into not only big architecture decisions, but, small component reviews, weekends, nights, sometimes holidays, right? Just all of the collective brain power and energy and effort put into this. And we had a get together just before the holiday, and all the team was talking about how much it means to them. Some people came to Lockheed Martin just specifically to work on this program, on this spacecraft. And after all of these years of effort, it's finally getting to fly. And we're just so excited and couldn't be looking forward to it anymore.
That's going to be such a thing. I think something people don't necessarily realize, although maybe our audience does know this, how big those teams are and how many, collective nights and weekends have been put into this moment. And it's a tremendous effort by a lot of really talented people and dedicated people.
Passionate people. Yeah.
Exactly. Hey, so Tim, you were there for EFT1. Tell us how this one's going to feel.
Yeah, I mean, the going to the moon with Orion, as it was designed to do, as we've been planning for so long, it's executing the mission. And when I was Orion system architect and we were doing the changes to put into place the design we have today, and looking forward to this moment, it's so exciting. But even going back, I mean, our careers are around these types of programs. I moved from Philadelphia, where I grew up, to Denver just to work on the Orion spacecraft. That's how important it was to me. And when I think back to, the fourth grader Tim that decided to be an aerospace engineer, it's this moment when we send our vehicle ready for its final test before crew to the moon that not just my career, but the whole Lockheed Martin and NASA team has been devoted their life to this mission because it's so important.
I'm a little older than you, Tim, and I grew up in Florida, just south of the Cape. And I grew up in the Apollo era. And one of the things, many of the people, my neighbors and our friends, were at Pratt & Whitney in West Palm Beach, which they had just opened in order to support the Apollo missions. And I was a little young to really feel that, other than I had a lot of friends whose parents were involved. But now it's ours. To see it happening, to see the VAB with a launch vehicle in it, and to see all of that active again, it's huge. It's huge for me to realize that we are not just having, spacecraft that are going once or twice or 4 or 5 times, but we're really going to be going and we're going to be staying. And, seeing this test flight and seeing that spacecraft come back is going to be so amazing. And I want to thank both of you and the hundreds and hundreds of other people involved for your roles and for making this remarkable moment happen. And on behalf of Spacemakers, thank you all for joining us. I hope you found our conversation as fascinating as I did.
You've been listening to Carrie Timmons, Tim Chihan, and Lisa May, and they are Spacemakers. Also, a very special thanks to Lisa for moderating the roundtable discussion. Whether you're a software engineer, systems engineer, finance, or HR professional, we need Spacemakers like you to help make this seemingly impossible missions a reality. Please visit this episode's show notes to learn more about the Artemis program or the careers available at Lockheed Martin. If you enjoyed this show, please like and subscribe so others can find us and follow along for more out-of-this-world stories. For Lockheed Martin Space, headquartered in Denver, Colorado, join us on the next episode as we introduce you to more Spacemakers. Spacemakers is a production of Lockheed Martin Space. It's executive produced by Pavan Desai. Senior producer is Natalia Oleksik. Senior producer, writer, and host is Ben Dinsmore. Sound design and audio mastered by Julian Giraldo. Graphic design by Tim Rush. Marketing and recruiting by Joe Portnoy, Shannon Myers, and Stephanie Dixon. These stories would not be possible without the support from our communication professionals, Tracy Weiss, Gary Napier, Lauren Duda, and Danny Hoff. Thanks for joining us, and see you next time.